Oops. What happened there?
Say again?
Have you got time to do a do-over?
Sure.
I'm so sorry. But at least we know where the interview's going, right? G'day guys, welcome to Lubrication Explained. Today I'm going to start off a new interview series, which I'm really excited about. It's going to be a little bit longer form, so slightly different to the videos that I have been doing. Today I'm going to focus on grease analysis, and I've got a really exciting guest. His name's Rich Wurzbach, a bit of an innovator in grease technology and specifically around grease analysis. And the reason I wanted to have him on is because, I go to sites and everyone's doing oil analysis. Some people are doing it well, some people are doing it poorly, but everyone does it. But grease analysis is just this big blind spot that no one really does any kind of grease testing. And I think that there's a huge opportunity. I talk about oils, lubricants and greases being very undervalued. This is an example where if we can get grease analysis right, I think that there's huge opportunity in industry to realize a lot of value and help protect equipment. So I thought that the discussion was really good. I learnt a lot, so I hope you will too. As usual, if you've got questions or comments, leave them in the comment section below. And yeah, let's get into it. Hey, thanks so much, Rich, for joining us. You are my first victim as far as this... I'm going to call it a show, I guess, or maybe it gets turned into a podcast or something. I'll have to come up with a name. Maybe it's like Tea with Mr. Ellie or something like that. But yeah, really appreciate you coming on here. And we're going to talk about sort of grease and specifically grease analysis, give sort of a state of play of the industry and things like that. But if you could please get us started with just a bit about your background, maybe where you came from and how you came into grease analysis and the industry, and maybe also your background in at MRG Labs and sort of when that started up and all that kind of thing.
Great. Well, Rafe, thank you for inviting me to participate. I'm real excited to be here with you, and I've seen some of the work you've done so far. So I'm glad you asked me, and this will be great. Yeah, I started back in the late 1980s. I started in the nuclear power industry in the United States, and almost right off the bat, I was asked to set up a laboratory there and look at some of the critical equipment. And almost immediately, some of the concerns we had were about grease lubricated equipment. So I dived right into it and got some samples and started looking at things like grease lubricated couplings and motor operated valve gearboxes that were grease lubricated. But I think when it really started to hit home for me was when I was working later at the National Institutes of Health here in the States, and trying to address the critical components there, which were almost all grease lubricated: exhaust fans and air handler units and vacuum pumps and the motors that drive them. And so that's where we had to evaluate and find out, how can we get a good sample, how big of a sample can we get, and then what can we do with it? What can we do with a small grease sample? And so that's when I started into developing the grease thief and the analysis tools that go along with it, with MRG Labs. And that's how we got to where we are today.
Oh, cool. So how long have you at MRG been doing grease testing?
It really, I'd say probably about 2008, we started looking into things and started to do some early kind of R&D, because that's where it was. Most people said you can't do grease analysis. It's too hard to get a sample. The tests that are available for grease require huge amounts of grease, and you can never get that much. So it's pretty discouraging at first, but we kind of pressed on and we tried some different things, and we were fortunate to come up with a method that is based on a 1 gram grease sample. And we got it now to where you've got 10 different tests you can do in the laboratory with that small grease sample. So yeah, that's how we kind of got started here.
Yeah. Oh, that's really cool. So maybe if we can back up and talk about the industry as a whole, and maybe a bit of the state of grease testing in the industry. Um, you know, the way that I understand that MRG has associations with a few labs around the world, and there's a couple, some competitors out there that are doing grease analysis as well. The thing that always kind of struck me was that whenever I go to sites, 99% of sites are doing oil analysis. It's just a standard part of the condition monitoring program. They may not be doing it well, but they're certainly taking samples and sending them to a lab. But when you ask how many of you are doing grease analysis, it's almost none. So what's the kind of like state of play in the industry? So, roughly how many labs would you say are out there kind of doing this testing? And what proportion of customers do you think are either doing grease analysis or maybe considering it?
Yeah, so I can speak confidently about the grease thief technology specifically, where we've helped 6 other labs around the world in Asia, North America, and Europe to set up a laboratory that uses the grease thief technology and the analyzer. But there's other laboratories too that'll do some level of testing, not to these standards or this approach, but some sort of grease analysis. But it's far less than the oil analysis that's being done out there, and that's true both in terms of what's happening in the laboratories as well as in the end users. Now, some industries are a little further along than others, but I'm sure it's less than 10%, that are doing grease analysis, and I think it's just a start. I think that we're going to see that grow. We're certainly seeing more inquiries about it. And I think people are just starting to realize there's an opportunity both to get a good sample and to do some meaningful analysis with it.
Yeah. Okay. So that kind of lends itself to the question is to sort of why is it that grease testing has not been considered part of the standard toolkit, if you like? I always found it a little bit odd that in many of the sites that I'd go to, there'd be critical equipment, or in some cases, the most critical equipment, right? Like, single point failure equipment that was grease lubricated. And okay, you can monitor the equipment through VA and other condition monitoring techniques, but there was no visibility on the, current state of the grease. So I always kind of found that a little bit strange that it was this blind spot that seemed to be common to every customer in every industry. So why is that? Why has it been a historic blind spot?
Yeah, I think it's because of the fundamental differences in how we lubricate machines with grease or oil. When it comes to oil, regardless of what kind of reliability programs folks have and approach to condition monitoring and stuff, the machines typically have, if they're oil lubricated, a drain plug or a valve or something. Even if all they're doing is once a year draining the oil out and putting in fresh, there's a plug somewhere or a valve that's being used to do that. So if you could stick a bottle under that, you could allow it to flow into that bottle, and like you said, it might not be a good sample, but it is a sample, and they're checking the box and saying, yeah, we're doing oil analysis. On grease side, it's different. Grease is designed to stay in place. I mean, that's why we use grease, because we want it to be delivered to that component, that bearing or that gear or what have you, and stay in contact with it. So it's harder to get it back out again. Even if there is an access plug or a purge plug, a lot of times, grease isn't flowing out of there, or there may be a delay. You may add grease, and it could be hours later or maybe a day later that grease actually finally purges out of that location and no one's there to grab the sample. So I think unless you really think through and understand where the grease is within the machine and develop some tools like we have to kind of go get it, it's hard to get that grease sample. And I think that's really what has grease lagging behind oil analysis.
Yeah, that's interesting. And for anyone who's interested as well, Rich and I have talked previously about the fact that it's difficult to kind of visualize, I guess, how grease moves around a machine sometimes. And so actually on the MRG Labs YouTube channel, which I'll link in the description below, they've got a really cool video of, I think it's an electric motor, I can't remember, but with a sort of a clear plate on it, so that you can see that, when you're filling up with grease, what is the grease exactly doing, and how does it purge. So for anyone who's interested, I'll make sure I'll link that below.
Yeah, thanks. I mean, when we did that, it was kind of like for our own purposes first.
Yeah.
Because if we're going to say, let's go get a grease sample, and first off, I don't want to analyze something that I don't have confidence tells the story, right? If it's not representative, I don't want to waste my time analyzing it. So in the case of grease, you have to understand the flow dynamics a little bit, and that's what we've tried to do. I think that video is an example of that process that you go through to say, let's make sure we're getting a good sample.
Yeah, that's really interesting. All right, so maybe we can talk about some of the key differences between oil analysis and grease analysis. I think a lot of people who are watching this are going to be very familiar with oil analysis, so we sort of don't need to retread that ground. But it's almost like people are going to want to talk about grease analysis, and in their heads they're going to have oil analysis, right? So we kind of got to distinguish between the two and say, what makes grease analysis different? Maybe what makes it more challenging. Is there maybe if we start with the actual sampling, because you mentioned that sampling is a little bit trickier to do, with grease. And I know you guys have come up with some methods for how to actually get a sample. So maybe before you start, you've mentioned the term grease thief a couple of times. So grease thief kind of has two different meanings, right, in your world. So there's the grease thief technology, which you license out, which encompasses, sampling as well as testing of the grease sample. But sometimes when you talk about the grease thief, you're actually just referring to the kind of little sampling tool. Yeah, there we go. There's one.
Yeah, here's one here. So yeah, this is the grease thief that kind of prompts the name. And sometimes I think it maybe internationally, sometimes the translation gets lost. And I remember someone from a foreign country like, are you really wanting to use the thief? Is that really a good connotation? But it comes from a technical term. A sample thief is something that's used for a large tank where you want to sample, let's say, from the middle of that tank, not drain off the bottom or scoop off the top. And a thief would be a canister that would go to the middle of that and then be opened to take a sample from the center. And when you think about grease and the way grease sits within a housing, it's a bit similar in terms of the challenge. I don't want to get some grease that's stuck to the bottom of the machine that has never been in the bearings or does not represent what's happening right now in terms of the lubricant that's doing that job. I don't want the grease that I just pumped in that hasn't had a chance to be part of that bearing, that gear, whatever. I want to go in and thief that sample that's happening right now, that's part of that. And that's what the grease thief allows us to do. So this is the tool, and it has a thread here on the end. You can see this red piston in there that goes back and forth within the body. And so one way to use it is to thread that right into like a drain of a machine, and then just allow it to sit there and let purging grease be captured. And we talked about, that might not be when you're adding grease, it may be hours later. This way, it's going to capture that and instead of it falling down on the floor, being contaminated, being lost, or whatever. So that's one way. Another way is to kind of actively take a sample by going into the machine and getting close to a component in the machine. So there's two kinds of grease thieves. This is another one that looks the same at first until you notice this stinger probe that's out on the front. So now what you're able to do is start with this piston at the end. So right now, as I push it into the machine, no grease is being captured in this sampler until it gets to that component that I want to sample. And then piston does move, the chamber does fill, and now I have a grease sample that I extract that's representative of that component, that's adjacent to that component. Because unlike oil that circulates around through the machine, the amount of grease that's actively involved could be a very small layer that's very close to that moving part. And this just goes into differences in the ways of the way we call it the flow dynamics, or the viscoelastic behavior is very different between oils and greases. And so we have to recognize that and kind of use that to our advantage, that knowledge to our advantage when we're going in there to get that sample.
Mm. And I guess that kind of speaks to the fact that it's almost a whole different skill set, right? So we do have to train, lube techs and fitters and that to, how to take a representative sample when it comes to oil analysis, right? That's always been a challenge to get them to take a representative sample. Basic things like, don't leave the cap off. Try and use a sampling thief when you can. There's all that sort of knowledge and awareness that has to go into it. So I guess now we have to layer on, there's a new set of skills to using a grease thief or something similar. So that'll just be another kind of awareness thing. And I've seen you guys, do run training programs and that kind of thing for anyone who is interested.
Right, but I think fundamentally the point is the same: is that it's not good enough just to fill a container with oil or grease. The what you fill it with needs to be representative, whether it's oil or grease. And so for those programs that are going to see the maximum benefit, even on the oil analysis side, they're going to do the things that they need to do on a machine by machine basis to educate the people taking those samples so that they have the right tools, they're not cross-contaminating, and they're not taking from a dead leg within the machine. Grease is the approach to grease sampling is fundamentally the same. You got to have the right tools. You have to take the sample from the right location. There's just the tools are different, but the approach needs to be the same. That the expectation is that we educate people, we give them the right tools, we support them, and we make sure we get that good grease or oil sample so that the analysis we do is meaningful.
Yeah, that makes a lot of sense. All right, so then, as far as the customer goes, I guess with an oil sample, taking the sample, recording the data, you put it in a bottle and then you send it off to the lab, and that's kind of the end of your chain of custody, right? From the customer's standpoint. So that part of the process, is that the same for grease samples? I know you've got the grease thief and you put it in it's kind of like a clear, like a mailing container kind of thing. And then is the process the same? You just send it off to a lab that does, grease analysis, and you'll get results in a couple of days, or?
Yeah, it really is the same. So I can show you some of that. I think there's already one in here, but this would be a shipping tube, an example of a shipping tube that would come back to the laboratory, and in here is an already filled grease thief. So you can see the grease is already in there. It has this yellow plastic cap that goes over it to keep that in there, and then that gets dropped into the tube with a label and capped. So what comes back to the lab is going to be this, and in some ways, it's a little easier in terms of shipping because it's not a liquid, and there's certain shipping things that regard liquids. We just put it into a padded envelope, and you can put 8, 10, whatever, and send them back. And so from like customs and other shipping concerns, it tends to go a little bit easier and a little bit smoother. The other thing to think about is that when you have oil, oil is fluid, it's moving, it could spill, but it could also, things can settle and so forth. The nice thing about the shipping process or the delivery process to the lab is that grease holds everything in stasis. It holds it into a matrix, and so very little changes on its way to the laboratory. So from that perspective, grease is actually a little advantageous.
Yeah, I hadn't really thought about that. All right, so we've kind of stepped through sampling and then sending it off, and so once the sample actually gets to the lab, it's going to go through a battery of tests. How are those tests different from a standard slate of oil analysis tests, right? So I guess for anyone who's a little bit unfamiliar with oil analysis, you're going to get things like your basics, your viscosity, you'll get oxidation usually by infrared, your oxidation, nitration, and a couple of others, soot, water, blah, blah, blah. And then generally the bulk of the rest of the results come from ICP, which is, a measure of all the different metals within the sample.
Yeah.
Now, I guess one of the differences is going to be that within an oil, you just have base oil, additives, contaminants. But in our case with grease, we've also got the thickener component as well. So
That's right. Yeah.
maybe if we can talk through some of the different tests that you might do, and how does the presence of a thickener kind of affect some of the results there?
Sure. So it not only does it affect the tests you might do and how you do them, it also affects how the sample is handled in the laboratory.
Right.
So when you have an oil sample, one of the first things you do when you get it in a laboratory is you shake it up vigorously to resuspend the particulate, the moisture, et cetera, to try to create a homogeneous distribution within that oil sample. Because if you're going to do more than one test, you're going to be taking a piece here and a piece there and so forth, and you want whatever that is to be evenly distributed. But you could shake a grease container all day long, and you're not going to move anything around. So there is the potential and the reality that you've got to deal with the heterogeneity of your material in a grease. Now, do we always do that right for oils? Hopefully we get it shaken up well, we do get it distributed and so forth, but we just need to fundamentally treat grease differently. And so one of the tests that you would do would be a ferrous content test, okay? And we often do this with oil samples as well. Sometimes we just let that come out with iron levels in our metals, but other times we're looking at ferrous content because we want to see small particles and large particles, and really get a sense of the wear of the components, the bearings, the gears, what have you. In grease, we need to measure that differently because it might be heterogeneous. So we have a device that uses an induction coil where you take the entire grease thief, drop it into that coil, and it measures from top to bottom the representative nature of how much ferrous material is there, large, small, and everything in between. And that's a device called the FerroQ. It's an induction coil device. So all you have to do is drop it in and pull it back out again, and you get a calibrated value that's in parts per million ferrous debris.
So that
right off the bat, that's different.
Yeah, so that would be, I guess, analogous to the PQ index, right? For oil analysis testing.
It would be. It would be, and I know some folks have tried to, put a grease sample next to a PQ device, but if you understand how PQ works, it's not going to work well, and it's not going to be reliable for grease, because in a PQ, you're actually the material in that fluid is responding to that magnetic field and changing in response to it, whereas materials aren't moving in the grease, and you can't redistribute them, and they're not going to respond to that field. So this is a different kind of induction method that is really focused in on the unique properties of grease.
Okay. Yeah, really interesting.
So that's one thing, right? And then you mentioned viscosity. Well, we can't take the traditional methods to measure viscosity, but we do have a very important measure to do for used grease, and that is the consistency of the grease. So this goes to the thickener, as you mentioned. And what can happen over time is that thickener can break down and the grease can become soft. Sometimes you can have the thickener separate from the oil. Sometimes you can have it harden. There can be conditions where the grease dries out or hardens, or when we start mixing greases together, really strange things happen in terms of that performance. So to be able to evaluate that consistency change from what the new grease should be, that's where that grease thief analyzer comes into play. And we have to measure it in a way that measures the non-Newtonian fluid properties of the grease, and that's called the dye extrusion test.
Okay. So you can actually do that test with the relatively small sample quantities, because you were talking about a 1 gram sample.
1 gram. Yeah. Yep. Yeah. This is I don't have the whole machine here for you, but I've attached the extrusion dye to the grease thief. So that's why it's all integrated. That's why I talked about it being an integrated process. And when you expect a laboratory to do meaningful analysis with only 1 gram, conserving that material is really important. And so, even every time you transfer grease, it's hard to get it all off of whatever you're transferring. So here we make that part of the process. And this extrusion dye has a slot here at the end. You almost can't see it here, with this narrow slot that makes a 1 millimeter grease film. And we put this into the machine. We control the temperature at 30 degrees Celsius and then press down on that piston and force the grease out through the slot. And as we're doing that, we measure the load profile as the speed of the extrusion changes. And that really tells you about that non-Newtonian property of the grease. It tells you how that grease is going to behave in the machine when it's being pumped. It's going to tell you how it's going to behave when it gets sheared by the movement of the machine, and how that grease is going to then get out of the way when you're trying to pump in new grease. And so those properties are really a function of an extrusion process, of applying that force and seeing how grease behaves. And this is a way to characterize that and see if it has changed significantly from that new grease and the properties that we desire for our application.
Okay, cool. So now, one thing that you just referred to then was the comparison with new grease, right?
Yeah.
So you said
Yes.
we can compare it to how new grease would behave. So if that's the case, and let's say I'm trying to start up a new grease sampling program myself, does that mean that for the suite of greases that I'm using across the plant, I need to also send samples of the new grease to the lab so that it can kind of serve as a reference?
Yeah, and a lab like ours that's been doing this a long time has a pretty deep library of greases. Sure. And if somebody gets in a jam, they'll say, "Oh, that sample's sent. I can't really get my hands on that new grease, but here it is," and we may have it in our library, and we can use that. But I don't prefer that for a couple of reasons. And one is that there are formulation differences from time to time from these manufacturers, especially for small quantity things like antioxidants and things like that. And also, if we do get baseline samples from, let's say, the grease supply, like out of a grease gun or out of a new tube or something, or where you're storing greases, often we can actually find problems in the new grease that is very helpful in understanding systemic issues that your greasing program may be creating throughout your facility. So we do, and in our lab we don't charge for that analysis. We just say, hey, throw all your new greases in there, and we'll baseline them, we'll assign them, and then when you do the analysis, it's compared back to that baseline.
Okay, and then maybe again trying to compare back to a standard oil analysis test. So do you guys also do kind of metals content, or a version of ICP? Like how does that work?
Yeah, so there's different things for different folks. Sometimes folks come to grease analysis with kind of an idea of what they're looking for and what they expect, and sometimes it's built off of what they expected for their oil analysis, so they want to see more of the same. Other times, we look at it and say, what's the best for this particular component? And for greases, the majority of the components that are grease lubricated are ferrous in nature. We don't see a lot of like babbited materials and other exotic materials. It's usually ferrous. So that ferrous test can be really telling about the overall wear condition. And a lot of times that's enough to kind of stop and say, we screened this through, everything looks fine. There's nothing to look at further here. But we do utilize rotating disc electrode spectroscopy. So it's a method. It's kind of analogous to ICP, but it works a little bit better with the grease analysis, and it does give us up to around 20 different elements that we can get a picture of their concentrations. It has the same limitation of particle size that you get with oil analysis, and not everybody in the oil analysis world understands that or recognizes that. But it does look at the smallest particles and the dissolved particles. So it's very helpful for looking at additives and things that are dissolved and for very small wear modes. But when you get into large particles being generated by abrasion and adhesion and fatigue particles and so forth, you're starting to lose your ability to monitor them with, say, ICP or RDE. So for us, you put them together. You do the furrow Q measurement where you're looking at ferrous content of big and small particles, and then if it's warranted, also looking at the metal spectroscopy, maybe to look at additives. Where we find it real helpful for greases is that we haven't talked really yet about what problems are commonly found when folks start doing grease analysis, and the one that I'll share with you is grease mixing. It's a huge issue. And it's just like, back to the squeaky wheel gets the grease, right? Yeah. Well, someone walks along, they hear a noise. I got a grease gun. It might not be the right one, but I'll feel a lot better once I pump some grease in there. And if it's the wrong grease, we can have some serious problems. So that's part of what we monitor as well is there evidence of mixing of greases, and can we intervene and fix that condition?
Okay. Maybe just to back up a little bit, there's a question that I meant to ask and I forgot when we were talking about the rheology of grease. You mentioned, okay, it's non-Newtonian, and so we're measuring sort of the rheology properties. But at the same time, I guess the way that I would understand how a grease sort of works is it's a thickener holding a base oil, and in the application, it is fundamentally it's the base oil that's doing the lubrication. Right? Let's say
for the most part, yes.
Majority of the time, right? And I get that we lean
That's
on the
right.
thickener because, with calcium sulfonate, it's kind of an EP in and of itself and all that stuff. But it is the base oil. So what can we kind of, what information can we derive about the base oil from grease testing?
Yeah, so it's very tricky to, once you've got this mixture that is grease, the thickener itself changes the properties that you would otherwise measure as base oil viscosity. So it's very difficult to tease that out. Now, there are some advanced tools that you can use in a laboratory that's almost like a distillation process. It's called Soxhlet extraction, where you can use a solvent. It takes a very long time. And it's possible that the solvent kind of gets into the oil at the end and shifts the viscosity. It's really tricky, and I try to discourage folks from getting too hung up on that parameter. We try to make sure that we've got the right grease going in. There's a lot of tests that we can do to confirm that it is the right grease, and kind of rely on that viscous behavior. Now, the things that could change that could include oxidation, right? We could oxidize the grease, change the behavior, its film forming characteristics, and certainly would want to know that. So, while I've talked about a couple of instruments that are unique to grease analysis, the overall approach is to be able to leverage all this other oil analysis instrumentation once we handle it properly as a grease. And so one of those tests is indeed the FTIR test. So you look for oxidation there. You look for any kind of contaminants that may get in that might change that film forming characteristic in addition to oxidation, as well as mixtures of greases, which can interfere with that as well. So that's where we're kind of following those kind of changes.
Okay. And then the last one I really wanted to ask about was colorimetry. I can never get that word right, but
that was perfect.
Oh, okay, cool. Looking at the sort of the color change of grease, I've seen a little bit of information on how you guys can analyze it. It's kind of funny. The way that you guys talk about colorimetry is in quite a sophisticated way, right? Looking at color changes and what that tells you about the grease. When I first saw it, it kind of feels like we've come full circle on talking about colors in greases, because, at a very base level, I've heard people talk about, red grease is good and blue grease is bad, right? That's your most basic level of analysis. And then, as people get sort of more sophisticated, okay, color doesn't matter. It's just the dye that's put in the grease. And now we're sort of coming full circle and saying, well, actually, color does matter, and color change matters. And actually, the change in color can tell you quite a bit about the degradation mechanisms in the grease. So, if you could talk a little bit more about that, I thought it was kind of interesting.
Yeah, I don't know that I can say the red grease is good and the blue grease is bad, but what I do know is if you've been pumping in red grease and purple grease comes out, you've got a problem.
Yeah.
And so that's what, and really early on when I would start to get samples, some of the folks who would send me samples would say, I want you to analyze it. And I don't know what to tell you to look for, but I'm sending you this sample because it just doesn't look right. And there was something, and you really need to listen to the folks who are responsible for these assets, because often they have a sense of what is normal and what is not. They know when things are changing, and so there's something to that. So we have an extremely sophisticated analytical tool in our eye, and and we can see these things. In fact, we one of the applications we have is robots. So these are 6-axis industrial robots that are grease lubricated. And we worked with a local company that does the servicing of these robots. And we asked, can we go around with you as you do this work and pull some grease samples? And so we spent a day at some different sites, and we came back with these grease samples. And I said to the technician, I said, good. I said, I'll share the results with you and I'll tell you what we found. He said, oh, you're going to find problems with number 3, number 4, and number 7. I said, now, how do you know that? He goes, I'm not sure, but the grease doesn't look right to me. And sure enough, he was right. And to me, I said, now we've got to take, his name was Ben. We got to take Ben's powers of perception that are linked to his experience as a technician in taking the machine apart and turn it into something that's measurable, comparable, and that we can create criteria for. And that's what we did to create this method of grease colorimetry. And one of the things that we found about grease color is that grease color is a function of the thickness that you present it as. You can take certain greases and you've got a big clump of grease, and when you look at it, it looks black or brown or something nondescript. And then you take a thin layer of that, and you can try this yourself. You can take some greases and then just take it on a piece of white paper and push it along and make it get thinner and thinner as you go. And you'll see that it's different colors as you do that. So if you really want to measure something and have it be a reliable measurement, and have the comparison mean something, you have to be consistent in the thickness of which you present that grease for the measurement. That's what our grease colorimeter does. It comes with 3 spacers, and each of these spacers allows a grease to be squeezed between 2 surfaces to a known thickness. And those thicknesses happen to be 35 thousandths of an inch, 10 thousandths, and 5 thousandths. And what we find is that some greases are fairly translucent, and if you thin them out too much, all you see is the light shining through, so you don't get a color response. Other greases that are just dark or almost black don't let light through, but you take them down to 10 thousandths or 5 thousandths, and now you see it's actually a blue grease, and it is the same hue of blue, the same color of blue than the new grease is, because not all blues are the same, not all reds are the same. So we use the approach, the measurement that we use is called the CIE values, which oil analysis folks may be familiar with in the membrane patch colorimetry test. So we're using a similar approach, but the preparation of the grease is quite different.
Interesting. That's really, really cool. All right. So I've basically just got one last question for you, which is, in terms of using grease analysis to sort of drive maintenance decisions, right? So I think, of the people that are doing oil analysis, the vast majority are, when the results come back, they're just looking at alarms, effectively. Does the report have a red box, a yellow box, or a green box on it? Right. And if it's red, then I'll go do something about it. Now, obviously, we would like to get people into, trending and looking at larger trends, but I think a lot of condition monitoring programs aren't quite there yet. So how would we use the results from grease analysis to drive maintenance decisions?
Right. So I think that where people usually start is kind of like a machine condition focused approach, which is, tell me if this machine has a problem that I want to have to deal with soon, right? And oil analysis is used in that way often as well. But if you think about the ways in which we can really leverage oil analysis, part of that is to go to condition-based oil changes, right? And I know that's one of the big cost benefits that I had when I was in the nuclear power plant. We were changing oil out in every machine annually or even more often. And when we started to do oil analysis, we were able to save a tremendous amount of money. And this goes to sustainability, and an appropriate focus that we have as asset managers and just as people living in today's world, is to make sure that we're using resources effectively. And if we're just changing oil out without it really warranted, that's not very sustainable. So you can see now more and more folks are using the oil analysis data to drive those decisions. It can happen on the grease side as well, and it might be even more important. And this is why, because when we set up programs for greasing, it's often a very broad engineering set of assumptions about how long that grease will last. And we're out there and we'll put them all around. We're not going to sample re-grease one machine every 17 days and another every 43 days. They all get pushed around into some kind of frequency, right? And it very, very well may be that grease is nowhere near being at the end of its life. And so there's labor, there's material being disposed of, there's material being used that isn't necessary. It's not a sustainable process. So I'll give you two examples. One is an automotive manufacturer with a large fleet of robots. And from the manufacturer, the instructions are annually to change the grease out on these robots. And they look at it and say, well, that robot doesn't run that much. This one does a little painting job back and forth. Another one is picking up car bodies. Is that the same level of wear and tear on that grease? Obviously not. And so by working with them, we were able to help them optimize and create a condition-based greasing program that's saving them close to $60,000 a year.
Do you mind if I just jump in there? Because that sort of lends itself to another question, which is, with oil analysis, I think there are pretty well-established limits, right? So especially coming from the OEMs, most of the time they'll say, you are allowed to let iron reach 10 parts per million, or whatever the number is, right? To my knowledge, in the greasing world, we don't really have those limits coming from the OEMs, right? It tends to be more on a time interval, right? You re-grease your bearing every year, or purge it every year, or whatever. So how are we then building in kind of limits into our program, if that makes sense? Like, how does, if I'm doing grease analysis, how do I know when the number is a high number?
Yeah. So think for a moment why we grease, why we re-grease a machine. The reason we add new grease is that we believe the grease is at the end of its oxidative life. Okay, that's one reason. A second could be because it has suffered shear down. So its shear stability has changed in some way. It's hardened or softened or whatever. Another would be that there are contaminants getting into my machine and I'm using grease to purge them out, right? And then another one is similar, but it's the wear metals. Like, we don't want to, we circulate oil, and any wear that comes up kind of gets taken to the reservoir or filters or whatever. In grease, it's all cumulative from the beginning. All that particulate is sitting there. So we grease to flush those metal particles away so they don't become agents of future wear. But those are the drivers. It's purging contaminants, it's oxidation, end of oxidation life, it's breakdown of the shear, and its wear condition. So those are the conditions that we key in on. And we just finished a project for a military helicopter that's very well known, and we did some presentations on this, and I'm going to be sharing some of this in conferences later this year. But this is a fleet of 1,400 military helicopters around the world, and we looked at those parameters. We actually had 7 different parameters that we looked at, because we were looking at moisture, we were looking at sand and debris getting into there for purging purposes. We looked at the antioxidants in the grease and when we were getting to the end of the life. And what we found is that on this frame of this helicopter, which was every place had its own frequency of bringing it out of the field into the shop and then purging the grease out on like 28 different locations, we found that out of the 28, one of those frequencies was not often enough. Actually, the grease was oxidizing in the machine. So by sampling it and analyzing it and looking at it at the end of that established time-based frequency that you talk about, we found that was inadequate. The majority of the components, actually, we were able to double that interval. And some we had, a few that we had to, just 1 or 2, we had to leave the same. So now what you have instead is an extension of greasing intervals, that for that fleet of helicopters is going to save about $10 million per year. That's just in changing the frequency. And that's just in the time that it takes to pull that asset out of the field, perform this maintenance, use these resources, and send it back out again.
Wow, that's really cool. And like an awesome case study too, right? It just shows
Yeah,
the value of the information too.
absolutely.
All right. Cool. Well, hey, I really appreciate you taking the time to answer all my annoying questions about grease analysis. I learnt a ton just from our short time here together. So I think hopefully anyone who was watching this is going to find it equally valuable. And I guess if people have questions about sort of grease analysis in general, first of all, I'd encourage them to go to the MRG Labs YouTube channel. You guys have got some great kind of webinars and presentations on there that'll help kind of illustrate what grease analysis is all about. And I think, from the videos that I've seen, it's applied to a few different industries as well, right? You've got a video that's wind industry specific, and one on sampling and things like that. So go there.
Yep.
And then if people are interested, if anyone's watching this and wants to start up a grease monitoring program, then greasethief.com.
Yep.
Awesome. Cool.
Yeah, if you go to greasethief.com, there's like a little button, request a grease analysis or something like that. And it just starts the process where you can send some information, and me or someone on the staff will respond to that. And what we want to do first is find out about your application, right? We're not going to say, oh, it does this and that and the other thing. It's about, let's talk about your application. Let's find out what your reliability goals are, what your asset management goals are, and what kind of equipment it is, how we might get you some tools to help take a good sample. And once we have that figured out, how it can be analyzed. And some of it is sending it to the lab, but Rafe, we're also the colorimeter that I described and the FurrowQ ferrous detection, they're also in a mini lab form that someone could put in their own facility. So they can be screening samples and really seeing, how is this grease holding up? So, that experienced robot guy that said, that color, I know that's not right. You could have that same tool, right? That same kind of ability to take those measurements and say, these are all good, but here's a couple that I want to send to the lab and find out more about. So, those are the kind of things that we can help folks with and get them set up with. And that's what we're here to do. We'd love to do it.
Yeah. Awesome. Well, like I said, really appreciate your time. And, if people got a lot of questions in the comment section or anything like that, I'll try and respond to them. But we might have to do kind of like a round 2, maybe on a specific application or do a case study or something like that. So, yeah, I think it'd be
absolutely. I would love to do that. I'd love to do that. If you see a video, and it doesn't address your industry or whatever, reach out to us. We'll do it. We'll do a new one. We'll address it. And I look forward to getting together with you again, Rafe, and following up and keeping bringing good information to folks. So thank you for this forum and this opportunity. I think you're creating a great thing here.
Cool. All right. Thanks, Rich. I'll talk to you soon.
Okay. All right. Take care.